So I have a earbuds on because I am in another meeting, but I really want to make this video for ACH 285. This is example 3 from class that I did not solve, but it was for you guys to solve. Whoops, I am muted on Zoom, but initial values are either VC, the voltage across the computer at 0 minus, and voltage, the derivative of the voltage, and the current through the inductor, and the derivative at t equals 0 plus. The final values are always just the voltage and current, voltage across the capacitor and current through the inductor. So this problem here, people have had problem solving, so I am showing here how to solve. First, I want to make the circuit at t less than 0. T less than 0, this power supply is off, so we're going to leave it open. So current's off means open. I won't put any capacitors or inductors, and this switch is going to be closed. So this will be in, this will be in, and then is the 2.5K here. And the capacitor will be measuring things like here, VC at 0. Wow, this is 1 volt. This is 0.5. And this is the current through the inductor. So here's what happens. This is a 1 volt power supply, and I will redraw it here. This is 1 volt, and this is half a kilo ohm and half a kilo ohm. So what happens is, really, there's 0.5 volts here and 0.5 volts here by voltage division. And this is 0.5 and 0.5K. So the current, in principle, is going to go this way, because the voltage drop is in this direction. The current through the resistor is this way, but the current through the inductor is the opposite. So IL is minus IR, if I'm calling this IR, and it's minus 1 milliamp because it's 1 volt divided by 1 kilo ohm is 1 milliamp. And then the voltage across the capacitor, I start here on the plus side, and this is minus 1 volt, so VC is minus 1 plus this voltage here, which is 0.5 volts, which means minus 0.5 volts is the voltage across the capacitor. So I just found these two at 0 minus, and they transfer for 0 plus. So let me just write here that this is IL at 0 minus or 0 plus. This is VC at 0 minus. I realize this is probably not the simplest way to solve it, but hopefully you can actually, the simplest just looking here and seeing that it's half, minus half, and minus 1 milliamp. The next video I'll solve the t larger than 0.